session, we are going to cover cost structures, various types of cost structures, their decoding and applications. The topics that we are broadly going to cover are introduction to various concepts, the different types of cost structures, variable, fixed, mixed, and how to split these mixed costs using different methods, and problem solving. Now, what are the different types of cost structures that we see in organizations? Variable cost, which changes in direct proportion to the activity. Fixed cost, which does not change in relation to the activity, it remains fixed. Mixed cost, which is a blend of fixed and variable costs. Now, let's understand what is the need to get into the details of cost behavior. There are different questions which all business managers face, especially while doing the budgeting or analysis of how their costs have behaved over a period. So questions like, if I cut my production by X number of units, will my cost reduce by rupees Y? What should be my budgeted cost for next year? How can I optimize on the costs? What part of my manpower cost is fixed and what is variable? Considering change in the level of activity next year, how much cost should I estimate? Variable cost. Commonly known fact about variable cost is that it varies directly in proportion to the change in the level of activity. If production increases by 10%, cost also increases by 10%. Now, this activity is nothing but your cost driver. It could be your level of production, your man days, etc. Important to remember is that cost per unit remains constant, but in terms of absolute value, it changes. So this concept should never be mistaken with the fixed cost, because in terms of the absolute value, it is actually increasing as your activity level increases. Now, if we just take a look at a simple case study of a company which goes into digital marketing, this company which specializes in trips to Brazil, it entered into a partnership with National Geographic. So every time a visitor reads through National Geographic article mentioning the word Brazil, link of website ABC pops up, ABC company has to pay 20 cents each time the reader clicks on that link. So for ABC, this is nothing but a variable cost. Now, is this variable cost good or bad? The challenge here is to provide superior contextual reference, which can increase the likelihood of conversion of the cost per click into the revenue generation for ABC, while cost per click for ABC may be the same as that of its competitor. Effective cost of ABC would be higher if, let's say, ads of ABC are clicked 0.7% times versus 0.2% that of the competitor, which means the conversion ratio in case of ABC is lesser than that of its competitor. Let's take a look at different types of variable costs that we have. There are true variable costs, which are moving directly in proportion to the increase in output. So any amount, it's important to note here that any amount purchased but not utilized can be stored. For example, your raw materials, which can be stored if not utilized during a certain period and can be carried forward to the next period. Cost. Now, what is the other type of variable cost? Is the step variable cost, where cost of resources is obtained in large chunks. For example, if you take example of number of tourists and the guides, cost of guides for servicing the number of tourists. Let's say if one tourist guide can attend to 5 tourists at a point of time, so up to 5 tourists the cost remains constant. However, as soon as it jumps to even 6 number of tourists, there has to be one more guide hired. So therefore there is a step jump. So this type of cost is known as the step variable cost, where cost is obtained in cost is incurred in large chunks, and it varies in response to a fairly wide change in the level of activity. Now, the same example we can also see in, for example, schools where there is child to school teacher ratio. for example, 30 students to a teacher. So every time there are multiples, so the number increases beyond 30, then one more teacher has to be hired and so on. Now, what is fixed cost? As we all know, it remains fixed over a period of time. For example, rent of a building is a fixed cost. Cost in total remains constant, but it increases or decreases in per unit on a per unit basis. As you can see in the graph, that while the fixed cost remains constant at $5,000, no matter what the output range is, but the cost per unit, as you keep increasing your output on a per unit basis, it keeps on reducing down from 20 to up to 5 and further down. Now, what are different types of fixed costs? In fixed cost also we have committed and discretionary fixed cost. Committed are the ones which are committed over a long duration of time by an organization. For example, setting up of a new manufacturing location, that becomes a commitment over a longer period of time. Or for example, hiring of senior management staff basis a certain organization structure. Whereas discretionary fixed costs are usually the ones which are committed only up to, let's say, 1 year time duration, and they can be changed after a year or sometimes even within a year without doing any changes to the goals of the organization. Whereas committed fixed cost cannot be so easily changed. To understand on how to optimize on fixed cost, let's take a look at a case study of Intel manufacturing computer chip manufacturing organization. It already had all 7 plants and it invested committed fixed costs. It invested into committed fixed cost in 5 new sites which were capable of manufacturing 1.25 million chips per day, that is approximately 375 million chips per annum. Now, new plants slashed production cost into half, as output of new plants was greater than the old by 2.5 times. This is nothing but economies of scale, where despite incurring huge fixed costs, cost per unit comes. Let's take a look at the third type of cost, which is mixed cost. So as the name suggests, it is a mix of fixed and variable cost. How do we represent mixed cost in way of a formula? It is y is equal to a plus bx, where y is total cost, a is fixed cost, b is variable cost, and x is the number of units. There are 3 different ways of splitting mixed cost which are explained in this module. One is your use of Scattergraph, which is a quick method of computing the fixed and the variable components of mixed cost. For example, if we study this data set of different months from Jan to July, the output and the maintenance cost at those level of outputs, and if we draw a scatter graph using a simple Excel file, or in the presentation, you can see there are different bubbles which you see here are nothing but the maintenance cost at different levels of output. If then you select the trend line and you extend the trend line to the y-axis where you've plotted maintenance costs, and the point of intersection of this trend line and the y-axis is nothing but the point of fixed cost. This is called as the point of intercept, which is in this case $3,300. So therefore, if we were to split the total cost between fixed and variable, total maintenance cost, let's say at $6,200 in the month of July, was $7,800, less estimated fixed cost, which you have computed using the scatter graph, comes to $3,300. So therefore, the estimated variable cost is $7,800 minus $3,300, that is $4,500. Variable cost per unit therefore comes to 4,500 divided by the output, which is 6,200, at 0.73. So therefore, you can represent your cost equation as y is equal to 3,300, which is fixed cost, plus 0.73x, where x is the output. This equation you can use to forecast your costs at even different levels of output beyond the month of July as well. Let's look at the second method of splitting cost, which is high-low cost method, where using the same data set, if you see, variable cost calculation has to be done using the slope. Now the line which we saw, the graph which we saw in previous chart, had a point of intersection, point of intercept, which gave you the fixed cost, and the variable cost is nothing but the slope of the line. Now how do you calculate the slope is the difference between cost of high level activity minus cost of low activity level divided by the high activity level, which is the output, minus the low activity level. Here in this case, as you can see in the data set, 9,800 is the highest value, 7,400 is the lowest cost value. So difference between the two divided by their corresponding output levels, which is 8,000 minus 5,000, which gives you 80 cents as the cost, variable cost. This is your variable cost, so therefore fixed cost will be total cost minus the variable cost, which in case of June, for example, your total cost was 9,800 minus 0.8 into 8,000 units gives you 3,000. Now the third method, if we look at, which is the least squares regression method, which is the most precise method amongst the three. Using all data sets, you can go to a simple Excel file, plot the data over there, and use the formula of intercept, slope, and r-square values. So intercept is equal to intercept bracket. You use the range of data from C5 to C11, comma, B5 to B11 bracket close. You get the value of intercept, which is 3,430. This is nothing but your fixed cost. Slope, which is going to be your variable cost, formula for that in Excel will be equal to slope bracket star, the same range of data set, that is C5 to C11, comma, B5 to B11 will give you the variable cost 0.76 per unit. R square RSQ will give you the level of precision of your estimation, which in this case comes to 0.9898%. So therefore any number above 90% shows that your estimation, the values are more or less precise. Now if you were to draw this exactly on the graph, then you can see that r square is 0.98 and your point of intercept comes at 3,430 and your variable cost is 0.7. So what is your cost equation here is y is equal to 3,430 plus 0.76x. That becomes your cost equation in this case. This equation you can use for your forecasting purposes, and it also gives you an understanding of what your fixed costs are and what is your variable cost and what are the costs which you can control over a short term versus costs which you can control over a longer term. Take a look at one of the examples. Company ABC has observed the following processing costs at various levels of activity. Using least square regression method, let's try and find their monthly fixed cost and the variable costs. These are the data sets of 15 months of units which are produced and the related processing costs of manufacturing those units. So using the same methodology of regression analysis, you can find that the intercept, which is your fixed cost, is 29,600. Slope, which is your variable cost, comes to 2.05, and the r-square value is 96%. So therefore your cost equation becomes y is equal to 29,600 plus 2.06x, which you can use for your forecasting purposes and for decision making purposes.